Hello friends, this is Shachi. Welcome to my channel Track Chemistry. Hope you all are doing well. Today I am going to discuss a class 12 topic. The name of the topic is Structure of Carbonyl Group and Chemical Reactions of Aldehydes and Ketones Part 1. Before starting, I want to remind you to subscribe to my channel for getting information about further important uploads. And don't forget to like and share this video with your friends. So now come with me and let's crack chemistry. So the topics which I am going to cover today are structure of the carbonyl group, nucleophilic addition reactions, and chemical reactions of aldehydes and ketones. Friends, carbonyl carbon is sp2 hybridized. You must be knowing that there are 3 sp2 hybrid orbitals which lie at an angle of 120 degrees and the arrangement is trigonal planar. Each sp2 hybrid orbitals contain 1 electron. Fourth electron is present in unhybridized p orbital. This unhybridized p orbital of carbon atom overlaps with p orbital of oxygen and forms a pi bond. And the 3 sp2 hybridized orbitals of carbon atom form 3 sigma bonds. So we can see that all the 3 sigma bonds lie in one plane and the pi bond which consists of 2 lobes. These 2 lobes are present above and below this plane. In addition, oxygen atom consists of 2 lone pair of electrons we can see here. These lone pair of electrons are also called as unshared pair of electrons. So this is the structure of carbonyl carbon which consists of carbonyl carbon is sp2 hybridized, consists of 3 sigma bonds which lie in one plane and the pi bond consists of 2 lobes which lie above and below this plane. Whatever points I have explained you are written here for your convenience. One more point I would like to mention here. In carbonyl group, as oxygen is more electronegative, so carbonyl group will become polarized. It will become polarized means oxygen atom will acquire a negative charge and carbon atom will acquire a positive charge. Because of the development of positive charge on carbonyl carbon, it acts as an electrophilic center or Lewis acid. Why it is acting as an electrophilic center? You can simply understand because the meaning of electrophile is electron loving. As the carbon atom has acquired positive charge, definitely it is in search of electrons which have negative charge. Similarly, oxygen acquires negative charge, therefore it will act as a nucleophilic center or Lewis base. It is acting as a nucleophilic center because it has acquired negative charge. Nucleophile means nucleus loving. So nucleus is having positive charge. So nucleophiles are in search of positive charge. So oxygen acts as a nucleophilic center or as a Lewis base. Lewis base are those which are rich in electron pair. So we can say that resonance stabilization is taking place in carbonyl group. It consists of 2 resonating structures. Structure A is a neutral structure and structure B is a dipolar structure. Because of the development of these charges, the carbonyl group has enough dipole moment and it is more polar than ether. So whatever points I have discussed with you are written here in this slide. Now I will discuss chemical reactions of aldehydes and ketones. Since aldehydes and ketones both possess carbonyl functional group, they undergo similar chemical reactions. So now I'll discuss nucleophilic addition reactions. In class 11th you have studied that alkenes undergo electrophilic addition reactions. But contrary to alkenes, aldehydes and ketones undergo nucleophilic addition reactions. Now I will discuss mechanism of nucleophilic addition reactions with the help of this diagram. Just now I have discussed with you that in the case of aldehydes and ketones, the carbonyl carbon is sp2 hybridized. So this carbonyl carbon is sp2 hybridized. It consists of 3 sigma bonds which lie in one plane. And because of the difference in electronegativity, carbonyl carbon develops a partial positive charge and it acts as an electrophilic center. So nucleophile will attack on this electrophilic center. We can see that a nucleophile attacks the carbonyl carbon atom from the direction approximate perpendicular to the plane, as a result of which a tetrahedral intermediate is formed and the hybridization changes from sp2 to sp3. So this is the first step, which is the slowest step. Now the tetrahedral intermediate which is formed, this tetrahedral intermediate is called as alkoxide ion. This intermediate captures a proton from the medium and converts into addition product. So what is the final product? Final product involves the addition of a nucleophile on carbonyl carbon and addition of a proton on the carbonyl oxygen atom. I hope these points are clear to you. So whatever points I have discussed with you are written here in this slide. Now I am going to compare the reactivity of aldehydes and ketones. Friends, aldehydes are generally more reactive than ketones towards nucleophilic addition reactions. There are two reasons for this. First reason is the steric reason and the second reason is the electronic reason. First I will explain you the steric reason. For explaining a steric reason, I would like to discuss the structures of aldehydes and ketones with you. All of you know that in ketones, two bulky alkyl groups are attached on carbonyl carbon atom. So this is the structure of ketones. Now I will draw the structure of formaldehyde. In formaldehyde, two hydrogen atoms are attached to carbonyl carbon. So this is the structure of formaldehyde. Now I'll draw the structures of aldehydes other than formaldehyde. In aldehydes other than formaldehydes, one alkyl group and one hydrogen is attached to carbonyl carbon atom. So because of the presence of these bulky groups, the approach of nucleophile on electrophilic carbon becomes difficult. As in case of ketones, there are two bulky groups. So approach of a nucleophile on electrophilic carbon atom becomes very difficult. And this approach will be very easy in case of formaldehydes, and the attack of nucleophile will be easy in aldehydes. And as the formaldehyde consists of no alkyl group, so this attack will be most easy in the case of formaldehydes. So that was all about the steric reason. Now I would like to discuss about the electronic reasons. For explaining the electronic reason, again I am going to write the structures of aldehydes and ketones. This is the structure of ketones. Ketones consists of two alkyl groups attached to carbonyl carbon. Again, I am going to write the structure of aldehydes. This is the structure of aldehyde, which consists of one alkyl group and one hydrogen atom which are attached to carbonyl carbon. And in the last, I will draw the structure of formaldehyde, which consists of only two hydrogen atoms which are attached to carbonyl carbon. So these are aldehydes, and in the last, I have written the structure of formaldehyde. All of you have studied about inductive effect in class 11. So you must be knowing that alkyl groups show plus I effect. Plus I effect means they donate electrons towards the carbon atom. Because of the donation of electrons towards the carbonyl carbon atom, the electrophilicity of carbon will be reduced. And if the electrophilicity of carbon will be reduced, then the attack of nucleophile will become less. In the case of aldehydes, they have only one alkyl group, so therefore the carbonyl carbon atom will be more electrophilic in comparison to ketones. And in the last, I am coming to formaldehyde. As formaldehyde has no alkyl groups, so the carbon atom will be most electrophilic in this case. So I hope all these points are clear to you. Now, in the last, I would like to discuss a question based on the discussions which we have done just now. There's a question. In this question, they're asking out of benzaldehyde and propanol, which you consider to be more reactive. You have to give reason for your answer also. So here I have drawn the structure of benzaldehyde. Benzaldehyde is C6H5CHO. It consists of a CHO group which is attached to benzene ring. So from this structure you can see that resonance is taking place in benzaldehyde. So because of resonance, you can see that polarity of carbonyl carbon is reduced. But in case of propanol, which is CH3CH2CHO, no resonance or stabilization is taking place. Therefore, carbonyl group is more polar in comparison to benzaldehyde. So that's why towards nucleophilic addition reactions, propanol will be more reactive than benzaldehyde. So friends, I hope you enjoyed this video. Thank you so much for watching this video. Please subscribe my channel and don't forget to like and share this video with your friends. Thank you so much. Have a nice day.